Hello students, our chapter is mechanical properties of fluid and our article is shape of liquid drops on solid surface. Before learning this article, we just remember about angle of contact. We know about angle of contact, see its definition. The angle between the tangents drawn to the free surface of the liquid and the surface of solid at the point of contacts measured within the liquid. This is the definition of angle of contact, and we also learn about shape of meniscus as concave meniscus, convex meniscus, zero angle of contact, and conditions for convexity and concavity. Now, today we are going to learn about shape of liquid drops on solid surface. When a small surface of liquid drop on a plain solid surface, the liquid will either spread on the surface or will form droplets on the surface, which phenomenon will occur depends upon the surface tension of the liquid and the angle of contact between the liquid and the solid surface. Suppose theta be the angle of contact for the given solid liquid pair. Remember the figure. Let's suppose T1 is the force due to surface tension at the liquid solid interface. T2 is the force due to surface tension at the air solid interface, and T3 is the force due to surface tension at the air liquid interface. As the force due to surface tension is tangential to the surface in contact, directions of T1, T2 and T3 are shown in the figure. For equilibrium of the drop, T2 is equal to T1 plus T3 cos theta, then cos theta is equal to T2 minus T1 upon T3. Here see the figure, means shaded portion is the solid. T1 and T2 are opposite forces. T3 is resolved into two components, means along T1 its horizontal component is T3 cos theta, which is not shown in the figure, which balances the force T2. That's why for equilibrium of the drop, T2 is equal to T1 plus T3 cos theta. Therefore, we get cos theta is equal to T2 minus T1 upon T3. From this equation, we get following cases. Case first, if T2 is greater than T1 and T2 minus T1 is less than T3, cos theta is positive and the angle of contact is acute, which is shown in the following figure. See the figure. T1 and T2 are opposite forces. T3 is in air. So, angle made by the force T3 with horizontal force along T1, that is theta, which is acute. Now, see the second case. If T2 is less than T1 and T1 minus T2 is less than T3, cos theta is negative and the angle of contact is obtuse, which is as shown in the following figure. Here is also shaded portion is the solid. On the solid surface T1 and T2 are the forces. There is a one liquid drop. The angle made by the force T3 with the force T1, that is the obtuse angle. Now in third case, if T2 minus T1 is equal to T3, that means cos theta is equal to T2 minus T1 is equal to T3. Therefore numerator and denominator are same. That's why cos theta is equal to 1. And we know that cos theta is equal to 1, then value of theta is equal to 0. For this case, the theta is nearly equal to 0. That means angle of contact is nearly equal to 0. Now, in fourth case, if T2 minus T1 is greater than T3 or T2 is greater than T1 plus T3, then value of cos theta becomes greater than 1, and which is impossible. The liquid spreads over the solid surface and drop will not be formed because here theta lies in the third quadrant. That's why the angle of contact theta is more than 180 degree. That's why it is impossible the liquid spread over the solid surface and the drop will not be formed. Now, our next article is factors affecting the angle of contact. Now, which factors affect the angle of contact? The value of angle of contact depends on the following factors. So, first factor, the nature of the liquid and the solid in contact. Second is which affects the angle of contact, impurity. Impurities present in the liquid change the angle of contact. Third factor, temperature of the liquid. Any increase in the temperature of a liquid decreases its angle of contact. Here also we know that for a given solid liquid surface, the angle of contact is constant at a given temperature. Now see from the following table, angle of contact for pair of liquid solid in contact. For first case, the angle of contact between pure water and clean glass is 0 degree. Second, angle of contact between chloroform with clean glass is also 0 degree. Third case, angle of contact between organic liquids with clean glass is 0. In fourth example, the angle of contact between ether with clean glass is 16 degree, means which is acute angle. In fifth case, angle of contact between kerosene with clean glass is 26 degree, which is also acute angle. In sixth case, angle of contact between water with paraffin is 107 degree, which becomes obtuse angle. And in seventh case, the angle of contact between mercury with clean glass is 140 degree, means this is also an obtuse angle. Now Our next article is effect of impurity and temperature on surface tension. Now, what is the effect of impurity? See, in this case, when a soluble substance such as a common salt is dissolved in water, the surface tension of water is decreases. We know that common salt means sodium chloride, that is NaCl. When that NaCl is added in the water, that time the surface tension of water is increases. Now second case, when a sparingly soluble substance such as phenol or detergent is mixed with water, surface tension of water decreases. In third case, when insoluble impurity is added into water, surface tension of water decreases. When impurity gets added to any liquid, the cohesive force of that liquid decreases, which affects the angle of contact, and hence the shape of meniscus is formed. If mercury gathers dust, then its surface tension is reduced. It does not form spherical droplets unless the dust is completely removed. Now, see the second case, that is B, effect of temperature. In most liquids, the temperature increases, surface tension decreases. For example, it is suggested that new cotton fabric should be washed in cool water. Why? Because in this case, water does not make good contact with the fabric due to its higher surface tension. The fabric does not lose its color because of this. That's why new clothes are washed in cold water. Now, hot water is used to remove tough stains on fabrics because of its lower surface tension. In this case of molten copper or molten cadmium, the surface tension increases with increase in its temperature. The surface tension of liquid becomes zero at the critical temperature. We know that what we call the critical temperature. The critical temperature means the surface tension of liquid is zero at the temperature. Such temperature is called as the critical temperature. Okay. Now, our next article is excess pressure across the free surface of the liquid. Every molecule on a liquid surface experiences forces due to surface tension which are tangential to the liquid surface at the rest. The direction of the resultant force of the surface tension acting on a molecule on the surface, on the liquid surface. This force also contributes in descending the pressure at the point just below the surface of liquid. Let's suppose A and B are the molecules. The molecule A is just above and the molecule B is just below the liquid surface. So, Fa be the force, downward force due to atmospheric pressure. See the figure A, plane liquid surface. Here shaded portion is the liquid On the liquid surface, there are 2 points A and B. A is just above the liquid surface and point B is just below the liquid surface. Ft are the tangential forces for the plane surface. Figure shows planar free surface of the liquid. In this case, the constant force due to surface tension Ft on the molecule at B is 0. The force Fa itself decides the pressure, and the pressure at A and B is the same. Now, B is the convex liquid surface. See the figure. A is the point on the liquid surface and B is the point just below the liquid surface. Fa is the atmospheric force which is directed in downward directions. Ft is the tangential force. Surface of liquid in figure is upward convex. In this case, the resultant force due to surface tension Ft on the molecule at B is vertically downwards and adds up to the downwards force Fa. This develops greater pressure at point B, which is inside the meniscus. Thus, the pressure on the concave side, that is inside the liquid, is greater than that on the convex side, that is outside the liquid. Third case, that is C, concave liquid surface. See the figure. Surface of liquid in figure is upward concave. In this case, the force due to surface tension Ft on the molecule at B is vertically upwards. The force Fa is due to atmospheric pressure, acts downwards. Forces Fa and Ft thus acts in opposite direction. Therefore, the net downward force responsible for the pressure at B is less than Fa. This develops a lesser pressure at point B, which is inside the liquid and on the convex side of the meniscus. Thus, the pressure on the concave side, that is inside the liquid. So, here the article shape of a liquid drop on solid surface and the factors affecting the angle of contact, and the article excess pressure across the free surface of liquid is finished. Now some questions are based on this topic, that is answer in brief. See the first question. Explain effect of impurities and temperature on the surface tension of the liquid. I just explain about the effect of impurities and temperature on the surface tension, give its detail. See the second question. Explain the condition for formation of the drops. That means the three forces T1, T2 and 3T. Explain its the expression about cos theta, that is T2 minus T1 upon T3. Now, and third question is explain that there is an excess pressure on the concave side relative to convex side of the curved liquid surface. That is the last article, give its explanation. Now we are going to see about some MCQs. See the first MCQ. At critical temperature, the surface tension of a liquid dash dash dash. See their options. Option A is infinite, B is 0, C is same and D is cannot be determined. Actually, this is the knowledge based question. So our answer is, that is the B. That is, at critical temperature, the surface tension of liquid is 0. Second MCQ, when temperature is increased, the surface tension of liquid dash dash dash. And their options are do not change, B is increases, C is decreases, D is none of these. Means when temperature increase, the surface tension of liquid is decrease. So our answer is, that is C. Third MCQ, the surface tension of liquid does not depends upon. See their options: nature of the liquid, B is temperature, C is presence of impurity, and D is the atmospheric pressure. This is also knowledge based question. The surface tension of a liquid does not depends upon atmospheric pressure. Okay. Now fourth question, fourth MCQ, excess pressure inside a drop and bubble of same radii and same liquid are in the ratio of, see their options: A 1:1, B 1:2, C 2:1, and D is 1:4. Means here we know the hints. Ratio of excess pressure inside a drop and bubble of same radii and the same liquid are 2T divided by R is to 4T divided by R. Therefore, our answer is 1:2. And last question, C. A drop of oil is placed on the surface of water. Which of the following is correct? Option A, it will remain on the shape, it will remain on it as a sphere. B, it will spread as a thin layer. C, it will partly be as a spherical droplet and partly as a thin film. And D, it will float as a distributed drop on water surface. So here our answer is B. That means a drop of oil is placed on a surface of water. Which of the following is correct? The answer is, it will be spread as a thin layer. Okay, thank you.